Yeah, let's get started. I'm videoing the classes from today, so I can't guarantee that every week's video is going to be up. I'll only put them up if the video is going to come out okay. I'm not embarrassed by them, okay? So, yeah, we'll try from today anyway. Right, so I'm going to go through the solution to Tuesday's lab. But before we do that, let's just have a little bit of a revision on the stuff that we did in Monday's class, okay? And then hopefully everybody has got their laptops. I see lots of laptops out. That's great. If you don't have a laptop, you'll just have to do today's class on pen and paper, because we're going to do some similar problems to the one we worked on Tuesday, okay? So let's try and remember a few things from last Monday's class. So we're using this framework called processing. Very simple question, first of all. What language is processing based on? Java. Excellent. Okay. So processing is a framework. All the programs in processing, what do we call them? They're called sketches, right? When we're writing a processing sketch, we have to first of all think about the coordinate system. So we have this y-axis going this way. Sorry, we have this axis, the y-axis there. Where do I put the x-axis? At the top or at the bottom? At the top, right? So that means the origin in processing is in the top left-hand corner of the screen. And for the x-axis, I count out from left to right. And for the y-axis, do I count from the bottom to the top or the top to the bottom? Top to bottom. Okay, so I go downwards on the y-axis. So the processing commands that we looked at, the methods that are built into processing. The first one we looked at was the line command, wasn't it? The line method. So we discovered that the line method takes 4 parameters. What are the 4 parameters that the line method takes?
X and Y.
Yeah, so it takes x1, y1, x2, and y2. So just a very simple example, if I was to give you this here, 20, 25, and then over 50 and down 100, what direction would that line go? It would be diagonal, starting from the top and going downwards, wouldn't it?
Yeah.
Alright, if anybody's not too sure about anything that I'm saying, then take the time to ask me a question now, okay? So that's how that coordinate system works in processing. Next method that we looked at in processing was how to draw kind of circular shapes. What's the method we use for drawing circular shapes? Ellipse. Okay. So we discovered that ellipse takes 4 parameters. What are the 4 parameters? Awesome. So the first 2 parameters are the x and y coordinates of the center of the ellipse, and the next 2 parameters is the width and the height. So we have w and h. If I wanted to draw a circle of radius 20, what parameters would I use for width and height? So listen to the question again. If I wanted to draw a circle of radius 20, what parameters would I use for width and height? 40 and 40, of course, because the radius is half the width, isn't it? Does everybody understand? If you take a circle, the radius is the distance from the center point of the circle to the outside. The width of the circle is equal to twice the radius. Is that okay with everybody? Give me some feedback if you understand.
Yeah.
Yes, good. Okay. So we have line, we have ellipse. If I wanted to just plot a single pixel on the screen, what method would I use? I would use the method point. This was one of your questions in the MCQ. How many parameters does point take?
2.
2 parameters. So what are those 2 parameters? The x and y. Alrighty. So we get x and y. Not forgetting that the Java language is the C language. What do we have to terminate each method call or each line of code with? Semicolon. Alright. And then we have these commas that we use to separate the parameters. So we got line, ellipse, point. If I want to draw, we'll say a square, what method would I use? Does anybody know? Rect. Okay. So we can also use rect. And rect takes how many parameters and what are they? Let's see if I've got a better marker. No better marker. So why don't I actually just type these up into a processing sketch then, so we can zoom it in. Okay, so if I wanted to draw a rectangle, I would use rect, or a box. What are the parameters that it takes?
4. X, Y.
So the first two parameters are going to be x and y coordinates of where? The
Width.
center or the top left?
Top left.
So these are the top left-hand coordinates of the rectangle, and then the second two parameters it takes?
Width and
The width and the height. So we have the x and y, and the width and the height. Not forgetting to put our semicolon at the end. So then we went through some colors in processing, and we realized we've got 3 methods for doing colors in processing. If I want to change the color that everything is drawn onto, what's the method that I use for that? Background. And we realize that there's 2 methods of this. This is a method which is overloaded for parameters. So there's a method that takes 1 parameter, isn't there? And what's the 1 parameter? What does it indicate? What does it tell the method?
color.
It's the grayscale. So the grayscale goes from what to what? It goes from black, which is what?
0.
0, and white, which is
255.
255. So the grayscale is some number that goes between, is gray G or EY or G or AY? I think it depends on which part of the world you come from. So we have some grayscale value that we pass in there, and that grayscale goes between 0 and 255. So that's going to change the background color. Next method that we have is to change the outline that's used to draw shapes. So what's that going to be? Stroke. So the same, we can use the one parameter version, or we can use a 3 parameter version. If I use 3 parameters for stroke, then what are the 3 parameters? So we have red,
Green.
green,
Blue.
and blue. And then we got close bracket and semicolon. So that changes the stroke color. And then if I want to change the color that shapes are filled in with, what's the method I use for that?
Fill.
Fill. So fill, similarly, there's a 1 parameter version and a 3 parameter version. So, you know what, that's like 90% of the processing code we'll use this semester. From here on, it's going to be for loops, while loops, if statements, all the stuff that you already hopefully know. Oh yeah, sorry, one other thing. If I want to change the color of, if I want to change the window size, what's the method I use for that? Yeah, cool. So I use size to change the window size. And how many parameters? 2 parameters. What are they? The width and the height. So if I was to do something like that, what shape would that be? Would it be a square, rectangle? Would it be vertical or horizontal? Say if I make it more straightforward like this, is that going to be a vertical or a horizontal window?
Like this.
That'll be a horizontal window because the width is 100 but the height is only 10.
Yeah.
Is that okay with everybody? So then we realized that we could divide our processing sketch into a couple of built-in methods which get called automatically by the processing framework. So the method that's going to get called right at the very start of our processing sketch, what's that? Setup. So any code that we want to happen at the very start of our sketch, we put inside this method, the setup method. So all the code that we want to execute at the start. So give me an example of something we might want to put into the setup method.
Size.
The size, right? So I want to set the size of the screen inside the setup method. And then there's a method which gets called once per frame in processing. And what's that? It's the draw method. And roughly how often does that method get called every second? It gets called 60 times a second because processing will try and maintain a frame rate of 60 FPS. So the draw method is going to get called 60 times per second. Alright, is that okay with everybody? Does anybody want to ask me any questions on that before we move on? Is that okay? Woo! Okay. So, now, let's try and do the lab, the solution for the lab, okay? Let's see, a couple of questions I wonder is it worth asking. First of all, how did you find the lab?
Difficult.
Difficult. Was it easy or difficult? Like, put up your hand. How many people thought it was easy? How many people thought it was difficult? Okay, alright. That's interesting. How many people didn't put up your hands? Put up your hands the third time. Was it like just okay then? Yeah. It was the right balance between easy and hard? Good. Okay, that's good feedback. Alright, so we'll try and do this anyway. Now, by the way, this type of problem that we're solving here, And what you're learning by solving a problem like this, you're learning lots of stuff. So you're learning how to write code, okay? You're learning the syntax of the language. You're learning how to deal with compiler errors. You're learning how to declare variables. Most importantly, you're learning how to use the for loop, which is something I guess you already did in first year. This problem that you're solving, it's a grid problem. And grid problems are all over the place in computer science. And I was just, thinking of a few examples this morning. Say, for example, you need to go through a Google Docs spreadsheet and extract some data. Your data is formatted into rows and columns. This is exactly the same type of algorithm you would write to solve that problem. Or if you're trying to get a robot to drive around a warehouse, and the warehouse is laid out into grids, grid fashion, rows and columns, and pick things off shelves in different locations. This is the same type of algorithm you would do. Or if you're trying to write an Android app, and you're trying to lay out your controls in a grid, so you want things to be in rows and columns. This is the same type of algorithm. So that's what you're learning when you try and solve a little problem like this. So that's the way I would approach this problem, is to solve it iteratively. In other words, I'll try and solve a simple problem, and then I'll build up to a slightly more complicated version of the problem, and I'll do it in stages. So let's do the first thing. Let's just draw the face. Now, looking at the little picture that we're trying to draw, the first thing we might want to do is we might want to draw the outside of the face. So let's pick a couple of numbers here as well, right? And let's do this like a programmer as well. Let's declare some variables. Let's go int x and int y. So int x and int y, when I declare them like this inside the draw method, what's the scope of these variables?
Local.
These are locally scoped variables. In other words, I can't use x and y outside of this draw method because I've declared it inside this block here. Is that okay with everybody? So blocks are really important when we're making our programs. So let's just assume that x and y for us is going to be the top left-hand corner of the face, and we'll draw everything relative to x and y. And this is a good way to solve this problem, because in a couple of minutes we're going to put a for loop around this, and we'll use the for loop to recalculate x and y. Okay, so let's draw our first circle. Why don't we be really cool about this and go, or should we? No, we'll keep it simple, okay? So, ellipse. Alright, so if x is the top left-hand corner of the circle that I want to draw, and let's imagine that the width of this is going to be 50 by 50. Width and height is 50 by 50. So what's the coordinates of the center point of the circle? Will be x plus 25, and let's just pick some numbers for this. Let's say x is equals to 100 and y is equals to 100. Or let's even be 100. That's cool. So then I want to go x plus 25. If I'm going to make my width and height of the circle 50 by 50, then 25 and 25 is going to be the center of it. So we have x plus 25 and y plus 25, and then let's go 50 comma 50. And that's going to give me the circle that I want to draw. So it's going to be a circle of radius 25, diameter 50. Alright, let's try and draw the nose. So the nose, pretty okay. It's probably the next easiest thing to draw, because the nose is going to be also in the center of the face. So we'll pick x plus 25, y plus 25, and let's make this a small circle. Let's try 5 and 5. And see what that looks like. Maybe it'll be too small. Maybe it'll be just right. Now let's draw the eyes. So when I'm thinking about the eyes, I know that the left eye is going to be over a little bit on the left from the center of the circle. So if it's 25 and 25 is the center of the circle, maybe if I don't subtract 25, if I subtract 15, then x plus 15 is going to be a little bit over from the left-hand side of the circle. Instead of going 25 as the center, 15 is going to be in the left-hand half of the screen. And then the y, okay, so if the center is 25, then I want to go up a bit on the y. So am I adding or subtracting to the y?
Subtraction.
To go up. Yeah, I'm subtracting. So let's go y plus 15, and let's try 5 and 5 for this. And now let's try the right eye. Let's try x plus, instead of 25, well, I subtracted 10 to get the left eye, so why don't I add 10 to get the right eye? So 25 becomes 35. And then this is going to be at the same height, because I want my eyes to be at the same height as each other. So we'll go 15, and then we'll go 5 and 5. And if you have your laptops open, feel free to type along, okay? Otherwise, yeah, by all means, take this down. So at this point, let's just run the sketch and see what happens. Make sure we've got no errors, and make sure we have something that looks, yeah, of course I changed the size, didn't I? So let's make that 500 and 500. Let's do some nice color stuff as well. Let's go background. So it's a bit easier to see. Let's go background 0, and stroke for white. Oh. For white, the stroke should be 255. Yeah, so all the full intensity of the grayscale, and then we'll run it, and of course, all those ellipses. Let's set the fill color. Let's set the fill to be 0, so it's going to fill black. Cool. So that's looking kind of face-like, yeah. Okay, let's do the next thing, the last thing. The last thing is the mouth, right? And so for the mouth, we're going to draw 3 lines. Let's draw one line for the bottom bit of the mouth. So let's make the mouth line up with the eyes, right? So for this, I can take x plus 15 for the start of it, and then y. So 25 is the center. Do I want to add or subtract from the y to go down further from the center? I want to add to the y, yeah, because the y goes downward. So 25 is the center. What do you think, 35? Let's try 35. Now, the far side of it is going to be x plus, so 25, let's go x plus 35. And then we want this to line up, so the y should be the same. So let's try running this here. See if that mouth looks kind of mouth-like. Cool. Looking good. He's looking indifferent. So why don't we try and make him smile? So if I want to make him smile, I want to put 2 little diagonal lines either side of that line. So the thing about these diagonal lines is I know that the start point of these diagonal lines is going to be the same as the start or end point of the previous line. So I can just copy and paste that down. And then I want to do a little diagonal thing. So if I want to do a diagonal thing, then maybe I need to subtract something from the x and subtract something from the y to get a point which is a little bit off to the left and a little bit up. So let's go x plus 15. So why don't we go x plus 5? And let's try, instead of y plus 35, let's say y plus 25. Yeah, just going to be a little bit higher up. And let's just see if what that looks like before we go. And okay, that's a very dramatic smile. That's okay though. Yeah, so 10 is maybe too much, you know. I get a Joker-like smile there, okay? So let's make our smile a little bit less smiley. He's happy, but he's not that happy. So instead of x plus 5, let's try x plus 10, and instead of y plus 25, let's try y plus 30, and then I will get a smaller smile. All right, that's looking more natural, kind of. Let's try the last bit then, okay? So the last bit of that line. So I know I'm going to take these coordinates here, which are the coordinates of the end point of the big line. And now what I want to do is x plus 35. So let's try x plus 40, because I want to go over a little bit. And instead of y plus 35, y plus 30 is correct. Yeah, because I want to bring my y up a little bit, and then hopefully I should have a little face. There we go, a smiling face. Joy. Alright? Is that okay with everybody? So that's the first thing. Now, because I've written my program and I use a variable to control where everything is drawn, I can change this x and y value and I'll get faces drawn at other locations. So if I was to change that to be 200 and 200, you know, by changing these one variable, my program is able to draw faces in different locations. And that's a really good principle of programming, right? Even in this program here, these numbers here, they kind of have a special name in computers. What do we call those numbers? That 50. You might have heard this term before. You might have heard Michael mention it. That number 50 there we call what type of number? You might have heard this term before. When you have hard-coded numbers like that in your program, what are they called? Have you heard the term before? What's that? No, there's a kind of a term that programmers use for numbers like that are just in your program, that are not variables. You might have heard the term, they're called magic numbers. Alright, so we refer to them as a magic number. It's a magic number because somebody's looking at that and going, 50. What does 50 mean? I mean, what's its significance to the program? It's just a number that we picked. Probably a better strategy for us would be to declare a variable and call it W, assign the value 50, and then everybody who sees it will know, okay, that's the width. You see what I mean? So also it makes our programs more flexible, because you can just change the value of one variable, the program goes and reruns, and you'll have changed everything. We could have written everything relative to two other variables. The other principle, so magic numbers in general in our programs are a bad idea. The other principle we want to try and employ when we're writing computer programs is the principle of trying to write the minimum amount of code to solve the problem and no more. Alright, so here's something, everybody write this down, okay? The best line of code you ever wrote. You'll hear me saying this a lot this semester. The best line of code you ever write. You got it? Okay, the best line of code you ever write is the line you didn't have to write. So we always try and write the minimal amount of code to solve a problem and no more. And there's lots of reasons for that. Reason number one is because every line of code you write in a computer program potentially introduces a bug. So if you could solve your problem using fewer lines of code, all the better. The other thing as well is, don't forget, every line of code needs to be executed on the CPU. So if you can solve your problem using fewer lines of code, then more than likely you've come up with a more efficient solution. And then the third reason why we try and write as little code as possible is because we are programmers, and that's what programmers do. We always strive to provide or to construct an elegant solution to a problem. We don't want to just put lots of code in there until it works. We want to construct an elegant solution in our minds, and we want to look at the code on the screen and be proud of the code and know that it's the best code that it could be. So we try and write as little as possible and make our programs elegant. So, next thing we wanted to do here is, we'll say just do one row across the screen of faces. So let's do that. So let's go for int I equals 0. Now we've got to think here. Let's say our screen is 500 wide and these faces are going to be 50 and I want 10 of them to go across the screen. So what shall I start x at? X is going to start, let's not do I, let's do x. For x equals 0, semicolon x is less than 500, the width of the screen, semicolon x plus equals to 50. So I'm going to start x at 0 and I'm going to add 50 to it each time around in the loop, and I'm going to do this bit of code that's inside the loop. So I'll put a bracket there, I will indent this block of code and put another bracket here. So now one other thing we need to do is just declare our y. So let's go y equals 100 here. So there's y and there's x, and if I zoom out and then run the sketch, there we go. So I've taken a program that draws one face, and by adding like one extra line of code, now I can draw lots of faces. Alrighty. So next thing we want to do is draw an entire screen full of faces. So instead of just using one value for I, let's use a loop to control the value of I. So for int y equals 0, semicolon, in fact, you know what, let's not use magic numbers, let's use width. Width being a built-in variable in processing that tells you the width of the window you're drawing onto. So let's go y is less than the height, semicolon, y plus equals to 50, and then we'll open bracket here, indent this block of code so that all my brackets line up and my code looks nice on the screen, which is really important as well. And now I have smiley faces going the width and height of the screen by adding 2 lines of code to a program that just draws a single face. I'm wondering, should I, can everybody see the screen okay? Maybe I should turn the lights off, yeah. Okay, I think I should just turn the lights off. At the front of the room if I can. Maybe it'll make the screen a bit easier to read. Yeah, is that okay? That's better, isn't it? So there we go. So now we have a little program with a nested for loop. Now, these patterns that you see, these appear all over the place, right? And we need to draw, you'll see them everywhere. If you start thinking in for loops, you'll see for loops everywhere in the world. Yeah, let's do this thing first. Let's make it happy and sad, okay? So, one of the questions that I asked you on the MCQ was the built-in data types in processing. So something that you might not, well, in fact you would never have used in C because it doesn't exist in C, is a new data type called a bool, a boolean. So, we already have ints. What's an int?
Integer.
What does that mean? Like the number 8.7 or pi, are they integers?
No.
No, they're not integers because integers are always whole numbers, right? What would happen if you assigned a number with something after the decimal point to an integer? Does it round up or round down? It what?
Ignores.
It ignores the bit after the decimal point, but mathematically would you say that that's rounding up or rounding down? Say if you took the number 5.5 or 5.7, you assigned it to an int, what would it be?
5.
It will be 5. So it always truncates the bit after the decimal point, right? And then we also have floats. So floats, we'll definitely do an entire class about floats. Floats are really interesting. And how they're stored in computers, they're stored completely differently to integers. They're not stored using 2's complement. You guys would have done 2's complement probably with Art last year, wouldn't you? Did you do 2's complement? Binary numbers? Did you know how to convert from decimal to binary, for example?
Yeah.
Yeah, so you use the divide by 2 technique and the other technique for getting back again, the powers technique. If you take a binary number like the number 1001 and you want to convert it to decimal, you know how to do that, I suppose, would you? Or hopefully?
Yeah.
Cool. What about 2's complement? How negative numbers are stored? Anyone? Flip the bits and add 1. Tell me you've done that.
Yeah.
Good, okay. So we'll do floating point numbers this semester because they're stored using a completely different format. Anyway, we also have this little thing in processing now and in Java called a Boolean. Booleans are really important. In fact, this here, if you think y is less than height, right, that's an example of a Boolean variable. Because what happens is, okay, so the y is either less than height, in which case it evaluates to true. And if the y is greater than height, it's going to evaluate to false. So that's an example of a Boolean variable. But we can also use Boolean variables in our programs as well. So let me declare a Boolean variable here, right? And let's call this Boolean variable happy. And let's say happy is going to have the initial value of true. So happy is true. And if happy is true, I want to draw my upturned face. And if happy is false, I want to draw the downturned face. So how do I make decisions in a computer program? I use the if statement. So I go if happy. Now we can do that because happy is a Boolean. So happy's got the value of either true or false. If happy is true, then that if happy thing will happen. Sometimes you see people writing this, which is equally valid, but not necessary. If happy is equals to true. I mean, both of these mean the same thing, right? Just if happy is the same as saying if happy is equals to true. If happy, let's draw these 2 lines. Else, let's draw a sad face. So now we'll take this code here, I'm going to bring it down to here, and I'm going to modify it, so I'm going to draw, instead of a happy face, I'm going to draw a sad face. So the x coordinates are going to be the same, but what will change here is the y coordinates. So instead of going 35, let's go 45. So 35 to 30, so that should be 40. Yeah, so I'm going to draw my face down instead of up, right? And just to show you if that works or not, let's change the happy variable to be false, and then run the sketch again. This is like your Monday face. And then we can make our Friday face just by changing one Boolean variable, and there we go. So we've made everything happy. If only life were that simple, huh? If only life were as simple as just changing your Boolean variable. Wouldn't it be great? Okay. So, if happy, I'm going to draw my upturned mouth, and if sad, I'm going to draw my downturned mouth. And what I want to do now is I want to flip that Boolean variable. Each time I draw something, I want to change happy to be false, and then the next time around happy is going to be true. I'm going to flip it. How do I flip something? How do I say something is equals to its opposite? How do you say not in programming? Exclamation mark. What's the proper name for the exclamation mark in programming? What's the name of the symbol? The symbol has a special name for programmers. Oh, you'll like it when I tell you if you don't know it already. It's called the bang symbol. Alright? So you go happy equals not happy. And what that will do is if happy is true, it will make it false. And if happy is false, it will make it true. And each time around in the for loop, I'm going to flip the value of happy from true to false. So happy starts out at true. I draw my face upturned. I flip its value so that now it becomes false. Next time around in the loop, it's going to be false. I flip it so it becomes true. So each time around, I do my happy sad face. I flip the value. So now I'm getting happy, sad, happy, sad, happy, sad face. Each time around, the Boolean value gets flipped from true to false. But it's still not 100% correct, right? Because the end here is sad, and then of course it flips it to be happy again. But really it'd be nice if it was kind of flipped going down as well. Any suggestions? Any suggestions as to how to get it to work? Sorry, just shout that out again with it.
Happy is equal to not happy in the first for loop.
Yes, exactly. At the end of the first for loop, I also want to split. That's probably the easiest thing. So I split every time around. Once I do an entire row, which is basically when I get to the end of the for loop, I flip it again. So I flip at the end as well. And then I've got to get happy, sad, happy, sad, happy, sad, all the way to the end. And then sad, happy, sad, happy. So every time I reach the end of a row, I also flip as well. Okay, so that is the program that we worked on in the class on Tuesday. Can I just have a quick check with everybody? So first of all, does anybody want to ask me any questions about how I did that? That solution is up on the Git repository now. If you go back to the README file on the Git repository, you'll see a link to it. So if you didn't manage to solve it on Tuesday, don't forget you signed a contract on Monday to agree to download the solution and run it yourselves and go through it line by line. So I'm expecting everybody to agree to the contract and do what you agreed to and to have downloaded this program before Monday's class and gone through it line by line. If there's something you don't understand, then ask me in the class on Monday or put some question up on the Slack and I'll answer it, okay? Or if you want to ask me any questions now, now's a good time. Who wants to ask a question? Everyone okay? Give me some feedback if everyone's okay.
Yeah.
Okay. Let us think about geometric patterns and get our laptops out and try and write some programs. Yesterday when I was thinking about this, I started immediately thinking about for loops, and everywhere I went, I saw nothing but for loops. And now I'm looking out at this class and all I see is one giant nested for loop. I see students sitting equally spaced in every chair, and I see chairs laid out in rows and columns. So what are you? To me, you're nothing more than a nested for loop, right? And looking at all of these geometric patterns and shapes that are everywhere in nature, and then also in things that we build ourselves. The shapes of patterns on leaves, they're all over the place. What's that? It's not. It's a nested for loop. And looking at this, what's this? This is just a for loop. Another for loop. You see those little curves, the way they're all geometrically laid out using the same patterns? Here's some more for loops. Look at this. There's a for loop. For loops. For loops. For loops all over the place. So everywhere we go, we see for loops, right? Will you guys get your processing sketch out and see if you can modify it to make the Dublin flag? Don't worry about the text or anything. Just generate that checkerboard pattern, okay? That's a very simple and it's sort of a smallish modification to the program, and then we'll try another one. Okay, so get your computers out if you have it now, modify the program to generate that, and use 2 different shades of blue, okay? Just for some practice. Now, let's press the stop button here.